Okay, here we are. Here we are. Welcome. Am I on? Good? Yes? Excellent. Here we are in God's country, Abu Dhabi. Okay? Don't trust anyone from Colorado. She lied to me. She went to her locker. We're in Abu Dhabi, and I think the locker was in Dubai. It's on the other side of the country. She took forever. She has detention until she's 40.
What?
You heard me. Okay. Now, I have people from all over here. We have Palestinians. Where are you from there again?
Lebanese.
Lebanese? Ooh, excellent. And you're home, right? You're UAE. What do you call yourself? An Emirati?
Emirati.
You're an Emirati. I'm not an Emirati. And you are South Korea? Excellent. Magnus is from Denmark. Denmark exists. I was curious. I just thought it was like a public relations thing, but it actually exists. We have a witness that Denmark is actually there. We have another Korean over there. He's very quiet. Very quiet. His name is Ed. He's yawning. He's very quiet. Okay. We have a Jordanian with us today. Excellent. Jordanian. Excellent accent. Okay. I only have 8 students in this class. All right. Yes. Yes. Again, don't trust anyone from Colorado. Rotten people. Okay, so what we're going to do today, in your periodic table, what is the atomic weight of hydrogen? Anybody? In your periodic table? Yes? 1. What? No. What? Give me everything. Yes? 1.0079. 1.0079. Okay. Well, how do you get 1.0079 if it only has one proton and electrons are negligible? How do you get 1.0079? Doesn't make any sense. Now let me ask you this: what's the mass number of hydrogen? What's the mass number? The mass number is the dominant isotope, right? We usually say that like hydrogen has a dominant isotope of protium. It is 1 proton, 0 neutrons, so the mass number is 1. Yes? So why don't we say that the atomic weight of hydrogen is just 1?
It's the average.
Because it's an average. Excellent. Now, we are going to completely make this up. Okay, I want to do an audience, what do you say, just to cover ourselves. This is not true, okay? Don't do this at home. It's too dangerous, okay? So what we'll say here is that this number here is actually an average based on, wait for it, isotopic abundances, okay? What does that mean? Now, there are true levels, but I just pick things that make a little sense, okay? 99.9% of all hydrogen we're going to say is protium. 99.9% is protium, correct? We're going to say that 0.09% of it is deuterium, and we're going to say that 0.01% is tritium. That's probably very high. Tritium is pretty negligible. Tritium is actually man-made. We make it in the laboratory. When we do, is it still on?
Yeah.
When we do fusion, we practice fusion, like the tokamak in the Princeton labs. $1 million a month back in the mid-'80s, the electricity bill to run the tokamak. $1 million a month. Wow, $1 million a month. So what we're going to do is I'm going to show you how you get these weird numbers. Like for instance, what's the atomic mass of chlorine? Anybody?
35.
Atomic weight.
35.45.
35.45. And we usually say it's 35. We say it has how many protons? How many protons have we said?
17.
It says, what's the atomic number of chlorine? 17. So we say it has 17 protons, and we say the rest are neutrons. So it'd have 18 neutrons, right? So where do you get this 35.45? And it is from the isotopic abundances. In other words, the atomic weight is the average of all the isotopes based on their abundance in nature. And the mass number is the number of protons and neutrons of the dominant isotope. That generally works for the lighter atoms as well. So let's do a calculation, shall we? You need your calculators out, and I need you sharp here, guys, okay? I need you sharp, okay? Miss Colorado is not prepared. She's going up out of her seat, walking to the back of the classroom, and getting her calculator that she should have had on her desk to begin with. But it's a Colorado thing, okay? Just want you to know that, all right? Now, I'm going to get some vicious mail from somebody from Colorado saying, no, we're really not that way, you know. So we'll say, so 99.9 times 1 is what? 99.9, right? Correct? Now, 0.09 times 2 is what? 0.09 times 2 is what? 0.18, right? Correct? 0.01 times 3 is what? 0.03. Add that up. 1, 0, no, sorry, that's 1, 1, right? 1, 1, and then 0, right? So 100.11, yes? Now, how many things did we use? Did we use 100? We're saying 100 particles, okay? If I say 99.9 of 100 particles, it's going to be 99.9, yes? 0.09, right, percent of 100 particles is going to be 0.18. So the answer is that you're dividing it by 100. So the answer is 1.0011. Right? Now, obviously, that's not correct. Yes, it's not correct, right? Because the answer is 1.0079. But the point is this. The point is this. That's how isotopic abundances are used to determine the atomic weight of an atom. Because when you see atomic weight on your periodic table and you say to yourself, well, how can atomic weight be a decimal if the atomic weight is the mass of the protons and neutrons? How do you have 0.13 or 0.0? What is hydrogen? 1.0079. How can you have 0.0079 of a proton? I mean, or is that the mass of the electrons? How do you get that? Well, the way you get it is through isotopic abundances. So what you would do is you would look up in a book, if you could actually find it, the isotopic abundances of each, and then you would do the calculation accordingly. Easy? Base your model on 100 particles, and 75% is this isotope, etc. Clear? Are we set? Now, you will have to do this on a quiz. I will give you the isotopic abundances, I'll give you everything you need, and then all you have to do is come up with the answer. Clear? Okay? God bless everyone, even from Colorado, okay? Wonderful people, I'm just kidding. Okay.
Oh, how sweet.
She's, I know, I'm telling you, I'm a charmer. Okay, bye.